Let's look at another one of these before we turn this video off. Find a power series for, oh man, f of x is equal to x cubed times x plus 2. Oh my god. All right, so here, let's see. Can we rewrite this algebraically in some kind of way? How about we do, let's just get rid of this x cubed. I'm just going to make it, put it out front and make this 1 over x plus 2 because we could probably handle that 1 over x plus 2. Have we done that one? No, it was a 4 over there. All right, so I'm going to leave this alone and then just basically find the power series for this guy here by rewriting it. 1 over, I'm going to switch the order, 2 plus x. I'll have to divide everything by 2. Wait, I wanted that to be in red. There we go. Divide everything by 2. Okay, and then I have 1/2. Looks like that's going to be my first term. Over 1. This is plus x over 2. I need it to be minus, so I'll make that minus a negative. X over 2, like so, right? All right, so then the power series for that part, summation from n equals 0 to infinity. My first term here is a half, and then I have a negative x over 2 that I'm raising to the nth power. Okay, so this negative, I will make that a -1 to the nth power as an alternator, and then give that power of n to both of these guys. So 1/2, that sticks around. I get a -1 to the nth power. I got an x to the nth and a 2 to the nth. Okay, so this time, see this 2 right here, that can come. Why is that an n to the nth power? Oh gosh, it's made that way more difficult. All right, anyway, so this 2 can combine up with this 2. This is to the first power. You add your exponents, so this one is going to be a n plus 1 power there. Alternator there, okay, and then x to the n over 2 to the n plus 1. All right, so that's basically this part, but we haven't dealt with the fact that we got rid of this x cubed. So this is equal to x cubed. Okay, so what I'm going to do here is basically I'm going to multiply all of these terms by x cubed, right? I could expand all of this thing out and then just multiply. This is like a distributive property that goes on forever, and distribute that x cubed to both of them, which would look sort of like this. Here, I'll do it like this. I'm going to go an x cubed, and then I'll put this little bracket here, and then I'm going to start building this series. Well, I can build it by just plugging in the numbers, or remember that my first term here is a half, right? And then my common ratio was -1/2, so I would multiply each of these terms by -1/2. So I'd have this multiplied times -1/2x, sorry, -1/2x, so minus x over 4, I believe, right? And then multiply it by -x again, -x over 2, so positive x squared multiplied by 2 again over 8 minus x to the third over times 2, 16, and then dot, dot, dot. Here, let's move this stuff over so we have some more room. And then we also have our nth term, -1 in x to the n over 2 to the n plus 1 plus dot, 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 keeps going. There we go. And then we would distribute this x to the third power to each one of these guys, giving us, here, let's actually put some little arrows there, just like it's Algebra 1. Our glory days. Okay, so this is going to be an x cubed over 2 minus an x to the fourth over 4. Notice I'm just adding 3 to each one of these exponents here, plus x to the fifth over 8 minus x cubed over, it's not cubed, it's, let's see, third to the 6th. Yeah, right? Wait, am I doing that right? Let's see. I'm supposed to add the exponents. Silly. All right. Oh, well, it's still adding. It would be a 6 either way. Anyway, right? So adding these two exponents, when you multiply on like basis, you add the exponents. Okay. All right. So my brain stopped working there for a second. That's still a 16 on the bottom. It's okay. It started again. So no need to call the paramedics. Maybe a psychologist, but not the paramedics. Okay. -1 to the nth. And then this guy would also get multiplied times this x to the third power right here, which is x to the, I'd have to add the exponent, so x to the n plus 3. It doesn't affect the 2 that's on the bottom, plus 1 plus dot, dot, dot. All right, so what that means is that our power series is actually, let's see, summation from n equals 0 to infinity, -1 to the n, x to the n plus 3 power over 2 to the n plus 1. So what we could have done right here, instead of expanding this thing out and done an infinite distributive property, is just take this into the third and bring it into the summation here and multiply it times the nth term here. Because essentially that's what happened whenever we did that distributive property. All right, and then is there anything else left to do? Probably. Let's see, we also need to find out what its interval of convergence is. That's super important. That's usually on the AP exam. By usually, I mean always. So let's go ahead and do it. And like, did we do this one geometrically? Well, sort of, but then it has this x cubed, which might mess some stuff up. I don't know. Let's just do the ratio test on it, shall we? All right, so when I do the ratio test, I'm going to take the limit as n goes to this thing, absolute value, and I would have -1 to the nth everywhere there is n. I'm going to add 1 to it, x to the n plus 1 plus 3, so n plus 4, over 2 to the n plus 1 plus 1, 2 to the n plus 2 power, and then we'll just multiply it by the reciprocal. I forgot the plus 1 on this one. Not that it matters because that's going to go away. All right, on the top, that's going to be our regular 2 to the n plus 1, and then down here, x to the n plus 3. Oh, I forgot this. That's important. Not really, because that guy's going to cancel. And then we can subtract our exponents on both the x's and on the 2's. Let's see, I have x to the n plus 4 divided by x to the n plus 3. Subtract those, you just get x up top. Boop. And then on the bottom, so those things are gone. Subtract the exponents. Let's see, this one's bigger on the bottom. When we subtract those exponents, we're going to be left with one factor of 2 here, which leaves us with this being equal to the absolute value of x over 2, which has to be less than 1. All right, so we've seen this thing play out before. Multiply the 2 over, and then fix this in between a -2 and a +2. And there you have it. All right, so what we were doing here is just some algebraic manipulation. We actually did some multiplication on this one, and on the previous one we did some composition in order to create a new power series for a known function.